So let's start with the questions of derivatives. So as you can see, the first one is 10x plus 2 ln 5x plus 1. So if I want to differentiate, as you can see, there is a product of two functions. So we are going to use product rule. It's going to be first into derivative of second. So ln 5x plus 1, again it's function under function. So derivative of ln x is 1 upon x. So 1 upon 5x plus 1 into derivative of whatever is inside, which is derivative of 5x plus 1, which is nothing but 5, plus second as it is, which is ln 5x plus 1 into derivative of 10x plus 2. I'm using a lot of brackets. Why? Because just to avoid silly mistakes. That's going to be 10. So finally it's going to be what? It's going to be, if you want, you can take out 2 common from here. So you'll get 2 5x plus 1 upon 5x plus 1 into 5 plus 10 ln of 5x plus 1. Of course, you can cancel this, and you will get 10 plus 10 ln 5x plus 1. That's your answer. Simple. Second one is differentiate with respect to x. Again, we are going to use product rule. Again, first, so 1 plus 4x to the power of 10 into derivative of second, which is minus sin x, plus cos x into derivative of 1 plus 4x to the power of 10. So it's going to be 10, like, x to the power of 10. So 10, 1 plus 4x to the power of 9 into derivative of whatever is inside. So derivative of 1 plus 4x is nothing but 4. And then if it is possible, we can simplify. So minus sin x 1 plus 4x to the power of 10 plus 10 into 4, 40. So 40 cos x 1 plus 4x to the power of 9. That's it. The second one, here it's a quotient rule. As you can see, numerator upon denominator. So denominator, that is tan x, into derivative of numerator, which is e to the power of 4x minus 5. I'll just write it for the first one. E to the power of 4x minus 5 minus numerator, which is e to the power of 4x minus 5 into derivative of denominator, so d dx of tan x upon denominator whole square, so tan x whole square. So it's going to be what? It's going to be tan x into, see, you're going to make a lot of mistake in this, so carefully do it. So derivative of e to the power of 4x minus 5, again we're going to consider e to the power of x. So derivative of e to the power of x is nothing but e to the power of x, which is 4x minus 5 into derivative of whatever is inside, so it's going to be 4 minus e to the power of 4x minus 5 as it is into derivative of tan x, which is nothing but sec square x upon denominator whole square, which is tan square x. See, whenever it comes to e to the power of something problem, better you take out e to the power of 4x minus 5. Mostly every time e to the power of x something will always be common. So just take out, just to simplify, it's going to be 4 tan x minus sec square x upon tan square x. That's your answer. You don't need to further simplify. Again, product rule, but here when x is equals to 0.3, you also have to find. So here again, dy by dx, product rule, first, that is x cube into derivative of second, which is 1 upon 2x plus 1 into whatever is inside, which is 2, plus ln of 2x plus 1 into derivative of second, which is nothing, first, which is nothing but 3x square. So you can just simplify. So 2x cube upon 2x plus 1 plus 3x square ln 2x plus 1. And they are asking dy by dx when x is equals to 0.3. So we'll just put dy by dx at x is equals to 0.3. We'll just substitute. We'll get 2 times 0.3 cube upon 2 times 0.3 plus 1 plus 3 times. Just put the values as in the calculator, and finally 2 times 0.3 plus 1 and so on. You just put it in the calculator and get the direct value. So after using calculator, you will get this value, that is 0.1606. Now the thing is, hence find the approximate increase in y when x increases from 0.3 to 0.3 plus h. See, they are not asking the value of f of 0.3 plus h. They are asking what is the amount of increment. See, this is going to be f of 0.3 plus h into f dash of 0.3. Now see, here we got f dash of x as this thing, and once we substituted, actually this was the value of f dash of 3. Now here they are just asking this much, the increment which has happened, and this is going to be how much? This is going to be just h into f dash of 0.3, which we already found. Sorry, this was not f dash of 3, this was f dash of 0.3, and which we already found, which was 0.1606, and that is nothing but 0.1606 into h. That's going to be the increment, the amount of increment which will happen. Same same type of question. Now here it's they have given that the derivative of this thing is something like this, and they are asking to write in this, and then they are asking you to find integral because of derivatives. So we'll see that. Now derivative of this thing is something k which we need to find. So derivative of 0.4x to the power of 5 is going to be what? So we'll just multiply, maybe we can use just product rule. Yeah, that is fine, first and second. So first, that is 0.4x to the power of 5 into derivative of ln 5 0.2 minus ln 5x, so it's going to be minus 1 upon 5x into derivative of 5x, which is nothing but 5, plus second, that is 0.2 minus ln 5x into derivative of this 0.4 x to the power of 5, so it's 0.4 will stay as it is into 5x to the power of 4. It's was a weird. So this is going to be what? 5 cancel, and you will get how much? You will get minus 0.4 x to the power of 5, I hope. Yeah. And then if I just multiply this 5 with 4, it's going to be 2, so this is going to be plus 0.2 minus ln 5x multiplied by 5 into 4 20, so 2x to the power of 4. At the end of the day, I'll get minus 0.4x to the power of 5. Okay, this 2x to the power of 4 will get multiplied here, so I'll get plus 0.4x to the power of 4 minus 2x to the power of 4 ln 5x. And actually we forgot something, that here x and this x to the power of 5 will become x to the power of 4, so we just forgot that. It's going to be 0.4 x to the power of 4. Actually that's what the calculation is. And then this is going to be 0.4 x to the power of 4, this gets cancelled, and finally we'll get minus 2x to the power of 4 ln 5x. So as you can see here, the k value is going to be what? It's going to be just the coefficient of this thing, which is going to be minus 2. Express ln 125 x cube in terms of ln 5x easily. It's just sort of ln, so we can write this and ln 5x to the power of 3, and which is nothing but 3 ln 5x. This is how we are going to write it in terms of this thing. Hence find the integral of this thing. As you can see, they have asked you integral of x to the power of 4 on whatever this thing. So x to the power of 4 ln 125 x cube dx. Now see, we know that derivative of this particular thing is kx to the power of 4. Like see, from this thing we know that derivative of 0. Just pay attention to this, 4x to the power of 5, 0.2 minus ln 5x is nothing but kx to the power of 4 ln 5x, and here k was nothing but minus 2. Now the thing is, if I just integrate both sides, okay, just pay attention, if I just integrate both sides, what I'm gonna get, something, see, d integral and then d dx is there, so this will be as it is, which is 0.4 x to the power of 5, 0.2 minus ln 5x. See, just it's like integral of derivative, so it's going to be the same thing. But here we wanted to find we just need to find x to the power of 4 ln 5x. Okay, we just need to find x to the power of 4 ln 5x thing. But here it is 125 x cube, so maybe we can just cube both sides, maybe we can just multiply by 3 or something like that. We are just going to modify a little bit. So what we need 125 x cube, here it is 5x. So what do we need? We actually need 5x to the power of 3 to make it 125. So maybe what we can do, we can just use this 3 ln 5x, and then I can make this as ln 125 x cube. So in short, if I just take out this minus 2 out, and I'll just multiply by x to the power 4 as it is, multiply by 3 ln 5x. I'm purposely multiplying by 3. I'll have to divide by 3 as well, just to keep that balance. And finally, this 3 ln 5x is nothing but ln of 125 x cube. So here, as you can see, this will be what? This will be minus 2 by 3 integral x to the power of 4 ln 5x to the power of 3. It's going to be ln 125 x cube. And this is nothing but your 0.4 x to the power of 5, 0.2 minus ln 5x. And now we are just going to shift this minus 2 by 3 to the other side. And finally what we will get, we'll get integral x to the power of 4, which was the question, 125 x cube is going to be what? I'm just going to multiply this 3 here, and I'll divide by 2. So this will become 0.2 into 3, so minus 0.6 x to the power of 5, 0.2 minus ln 5x plus c. So I know it's a weird question, but you need to understand. Just take a look at it later and just solve it. Another question, 1 plus ex to the power of x square x plus 5. So as you can see, they are asking you to find dy by dx. So dy by dx is going to be your first. So 1 plus e to the power of x to the power of 2 into derivative of second, which is x plus 5. So it's going to be 1 only, plus x plus 5 into derivative of e to the power of x square, which is going to be e to the power of x square into derivative of x square, which is nothing but 2x. Chain rule again. So at the end of the day, if you want, we can write it properly. 1 plus e to the power of x to the power of 2 plus 2x e to the power of x square x plus 5. So that's going to be your derivative for this thing. Find the approximate change in y as x increases from 0.5 to 0.5 plus p. Now see, there is a change of 0.5 to 0.5 plus p. So at the end of the day, what they are asking just how much it has increased. So it's going to be f dash of 0.5 plus into p. So in short, first we already got f dash of x, so we just need f dash of 0.5. So it's going to be what, we'll just put it in the calculator. So it's going to be 1 plus e to the power of I'll just make it 1 by 2 so that it's going to be easier. So 1 by 4 plus 2 into 1 by 2 into e to the power of 1 by 4, 0.2 square, that's why, into x plus 5. So 1 by 2 plus 5. Yeah, makes sense. So we'll just put it in the calculator and get the value. So after solving, we'll get f dash of 0.5 as 9.35. Now here comes an interesting part. So you see, y is increasing at a rate of 2 units per second when x is equals to 0.5. When x is equals to 0.5. So that means what they have given, that they have given dy by dt is nothing but 2 units per second. Find the corresponding rate of change in x. So that means what? So y, we already got that thing as f of x. Now if I want to find dy by dt, like if I just differentiate with respect to t, so I'll get dy by dt is equals to, this is going to be f dash of x into, that is nothing but I'm just differentiating with that x thing, into dx by dt. In related rates we'll get it better like when we solve the other question. So it's going to be f dash of x is equals to into dx by dt, like differentiating x with respect to t. And we already know this is nothing but 2 at what, at x is equals to 0.5, right? So we already know f dash of x. Again we are going to substitute 0.5, so we already know it is going to be 9.35. So it's going to be 9.35 into dx by dt, and all we need is this dx by dt. So dx by dt is going to be what? Dx by dt is going to be 2 by 9.35. Again we are going to use calculator for this thing. So to divide this thing, and we'll get 0.213 units per second. That's your answer. Okay, now look at this question. A curve has equation y is equals to 4 plus 5 sine 3x. Find dy by dx. So derivative is going to be very simple. So dy by dx, derivative of constant is 0. So 0 plus 5 constant outside. Derivative of sine 3x is cos 3x into derivative of 3x, which is nothing but 3. Chain rule again, which is nothing but 15 cos 3x. Very simple. I mean, why they are giving 2 marks for this thing? Anyways, now hence find the equation of tangent. Now see, as I told you, for equation of tangent, where we were, where is it, just a second, yeah, this thing, application of application of derivative, in that we had this tangent. So for finding the tangent, what we require, we just need, so this is nothing but your f dash of x, right? So we need f dash of x at what, at x is equals to pi by 3, tangent at x is equals to pi by 3. See, there are many tangents. You put any values of x, 1 2 3 4 5 6 1000 10,000, you will get tangents at those points, but they are asking only at pi by 3. So we'll just put f dash of pi by 3. That will give us the gradient n, right? So this is going to be 15 into cos of 3 into pi by 3. 3 3 cancel, and we'll get 15 cos pi. Now cos pi is how much? Cos pi is nothing but minus 1, right? So this is going to be minus 15. So this is nothing but my gradient. But for the equation of tangent or equation of line, we require two things: gradient and coordinate. So for coordinate, we know the x coordinate is pi by 3. All we need is y coordinate. So for y coordinate, we just put x in this thing. So we'll get y is equals to 4 plus 5 sine of, again, 3 into pi by 3. This time it's going to be 4 plus 5 sine pi, and this is nothing but 4 plus sine pi is how much? Sine pi is going to be 0. So this is going to be 0. At the end of the day, y is nothing but 4. So the coordinate we got is pi by 3 comma 4. Now we just need to find an equation of line passing through pi by 3, 4, and gradient minus 15. So we'll get y is equals to minus 15x plus c. For finding the value of c, we'll just substitute pi by 3 comma 4 in this equation. We'll get 4 is equals to minus 15 into pi by 3 plus c, which is nothing but 4 is equals to minus 5 pi plus c, or c is equals to 4 plus 5 pi. This we will substitute in this equation and we'll get y is equals to minus 15x plus 4 plus pi. If you want, you can keep it in decimal, I mean 4 plus 5 pi, and then you will get the answer. The last two questions, related rates and stationary points. Now think about it. The volume V and surface area S of a sphere are given by whatever those formula. The volume of a sphere increases. Now see, whenever you get these kind of a question, better you write the given condition first. The moment I got volume of a sphere is increasing at the rate of 200 centimeter cube per second. So that means what they have given, dV by dt, rate of change of volume. So dV by dt is 200 centimeter cube per second, dV by dt. At the instant when the radius of the sphere is 10 centimeter, when r is equal to 10 centimeter, see, radius is increasing, volume will increase. Like see, you're blowing a balloon, you can understand, right? Starting you will see that the balloon will grow like this, but then eventually, even if you pump a lot of air, that time also it will just slowly increase. So but dV by dt, the amount of air you are filling in the balloon is constant, but here the volume with which it will change, or something, or like, with which the radius will change or anything will change, be it surface area, so that would be different. Now they have given V is equals to 4 by 3 pi r cube, so we'll just use that. V is equals to 4 by 3 pi r cube, at which the radius of the sphere is increasing. So they are asking this thing. So basically they are asking dr by dt is equals to question mark. Now see, as I told you here, see, if it would have been two variables, then I would have converted that into one variable, but here it is just one variable, that is r cube. So we're just gonna differentiate with respect to t, with respect to time t. So we'll get dv by dt is equals to 4 by 3 pi constant outside, derivative of r cube is nothing but 3r square into dr by dt, because we are differentiating r with respect to t. See, in general also, if I have y is equals to sine x, so derivative with respect to x is going to be, see, why we are differentiating with respect to x, so we get dy by dx. But if I differentiate sine x with respect to x, it's going to be cos x into dx by differentiating x with respect to dx. Now this becomes 1, that's why we don't write it, so we directly write cos x. Anyways, but here we are writing dr by dt. Now what we know dv by dt is 200. This is 4 by 3 pi. Acha, sorry, 3 gets cancelled, so we'll get 4 pi r square and dr by dt, which is what we need to find. But we already know that at what instant we need to find, when this radius of the sphere is 10 centimeters. So we are just going to substitute that. It's going to be 10 square. Now we will just solve it and we'll get what? So 200 by 400 pi is equals to dr by dt. In short, we'll get dr by dt is equals to 1 by 2 pi. Now see, rate of change of radius, right? Rate of change of radius, that's why it's going to be centimeter per second. Also, mathematically what will happen, see, this r square, so this is in centimeter square, this is centimeter cube per second. So if I divide centimeter square by this thing, so centimeter square and centimeter cube gets cancelled, and this will be centimeter per second, like, theoretically. The rate of increase of the surface area of the sphere, same logic. This time they are asking surface area, so they are asking ds by dt in short. They may ask you ds by dt also directly, huh? So for that also we'll have to follow the same procedure. Now see, what we need ds by dt, but we also know the formula, that is s is 4 pi r square. So ds by dt is going to be what? Ds by dt is going to be 4 pi into derivative of r square, so it's going to be 2r into dr by dt. Again 4 pi is constant, so it's going to be out. Now the thing is, we already know dr by dt this time, 1 by 2 pi. All we need is ds by dt, so it's going to be what? 4 pi into 2. At what instant? At the same instant when r is equals to 10, so we'll just put 10 into 1 by 2 pi. So this gets cancelled, this gets cancelled with 2, so we'll get 40 surface area, so centimeter square per second. That's going to be your answer. Now one more question. The volume of a closed cylinder of base radius x centimeter and height h centimeter is 500 centimeter cube. So they have, see, some of the quantities are constant. See, here everything was changing. Radius was changing, surface area was changing, volume was changing. No, volume was constant actually. Rate of change of volume was constant. So there is always a difference with respect to the scenario. The volume of a closed cylinder of base, radius x centimeter and height h centimeter is 500 centimeter cube. Express h in terms of x. See, I was saying you that you have to write everything in terms of one variable. So we are going to do that. So express h in terms of x. See, volume of closed cylinder. Volume of cylinder is pi r square h. Okay. So they have said that the volume is constant, which is 500 centimeter cube. So we'll get 500 is equals to pi r square h. Now they are asking what? Express h in terms of x. Actually, x is nothing but the radius. So yeah, like that. So h in terms of x. So h is going to be what? It's going to be 500 by pi x square. That's going to be the height. So in terms of x. Now show that the total surface area of the cylinder is given by this thing. Now total surface area is what? It's going to be surface area of a cylinder. If you know, it's going to be the two circles. So 2 pi r square plus circumference into height. So that's going to be the total surface area. So 2 pi r into h. Here r is nothing but x. So it's going to be 2 pi x square plus 2 pi x. But see, we need to write everything in terms of one variable. Why? Because for the next step, as you can see, they're asking you the stationary value. So remember, I told you, write the function in terms of one variable only. Optimization. Remember this thing, I said one variable. So that's the reason we are doing it. So now, okay, sorry. So 2 pi x into h. H is nothing but 500 by pi x square. Of course, you can cancel this, and you will get 2 pi x square plus 1000 by x centimeter square. That is your surface area. Now given that x can vary, see, we can change the radius basically. Okay, so height will automatically will vary because there is a relation between this thing, height and x, height and that radius, and this will change according to the one constant, which is volume. So volume is constant, but surface area can change. So basically you can imagine that if I have this can and I want to in the least surface area I want to make the maximum output, that is maximum volume. So what could be the value? Generally remember that when it comes to rectangle also, okay, mostly when it's a rectangle also, so if I want to like you know, I want to take lesser amount of perimeter but maximum output, that is maximum area, then it is always going to be a symmetrical shape, be it circle, square or something like that. So it is always going to be like that, like it's called always symmetrical. So mostly we'll get a symmetrical value. So now what they are asking, given that x can be, find the stationary value of a and show that this value is a minimum. So we need to find the value of x for which it will have minimum surface area. So what we are going to do, we are just going to do f dash of x. So this will consider as f of x. So f dash of x is going to be what? It's going to be 4 pi x plus derivative of 1 by x. It's going to be 1000, and this is nothing but x to the power of minus 1. So minus 1 into x to the power of minus 2. I hope you got it. See, f of x. So if I'm finding the derivative of 1 by x, x to the power of minus 1, which is nothing but minus 1 into x to the power of minus 2. So that way I have done. So this is nothing but 4 pi x plus, sorry, minus this time because of this minus 1000 by x square. That's going to be my derivative. Okay. Now the thing is, we want a stationary value. That means what? Maximum, minimum, that kind of stuff. So we'll just equate it to 0 to find out the value of x for which it's going to be minimum. So we'll just equate this to 0. So we'll get 4 pi x minus 1000 by x square is equal to 0. Now what we are going to do, we are just going to multiply everything by x square. So it's going to be what? It's got 4 pi x square minus sorry, x cube. It's going to be 4 pi x cube minus 1000 is equals to 0. So I'll get x cube is equals to 1000 by 4 pi, and finally I'll take the cube root of this thing. So it's going to be cube root of 1000 by 4 pi, which is nothing but, using calculator, which is nothing but 4.3 centimeter. So that's the value you will get. Now you just need to prove whether it's gonna be maximum or minimum. So what we are gonna do, we are just gonna double differentiate this thing. F dash of x, we got this thing. So f double dash of x is gonna be what? F double dash of x is gonna be 4 pi derivative. This one I'm talking about. Okay. So 4 pi minus, now again 1000 upon x square. So it's gonna be, I'll just consider this thing as, okay, let me just write down this f dash of x again. So f dash of x was 4 pi x minus 1000 x to the power of minus 2. Now derivative of this thing, that is double derivative, so f double dash of x is going to be what? It's going to be 4 pi, and this is going to be minus 1000 into x to the power minus 2 minus 2 into x to the power of minus 2 minus 1, which is nothing but minus 3. So as you can see, it's going to be 4 pi plus 2000 by x cube. Since x is positive, therefore f double dash of x will always be positive, and therefore we will have minimum. So therefore minima at x is equals to 4.3. Why? See, think about it. It's x cube. I know it could be negative, but the thing is, since x is positive and everything is positive, so we'll get positive f double dash of x, and hence we'll get the minima at that point. So that's all you have in derivatives. See, we have done related rates, derivative integration kind of stuff, then optimization, and all these things we have done. So please check out, and let's see for the next topic.